This is part 2 of 1.19 graphing. Alright, so I got cut off on that last recording. Sorry about that. So we were about to plot our next point when we realized we need to figure out how far apart each of the lines are. So the distance from one main line to the next main line is 20, which is easier to see here. Going from 130 to 150 is a total of 20. And it takes 1, 2, 3, 4 lines to accomplish that. So you take 20 divided by 4. And that tells us every line is 5 apart. So 130, 135, 140, 145, 150. So we need to plot 116 and 10. All right, so we're at the 10. Here's 110. Here's 115, and it's just a little bit above since it is 116. All right, now if you noticed, my dot's a little bit off. I really want it to be exactly in the center of the lines to show where it belongs. And that is important. So we want it exactly on that 10 line, a little bit above, and right there looks good. All right, 20 and 144. So here's 20. Here's 130. What's this one? 135. This one, 140. This one, 145. So we want it just a little bit below. And then 30 and 160. So 30, 150, 155, 160, and 40 and 185, 40 and 70, 75, 180, 185, and 50 and 195. So 90, 95. All right, let's see if it's going to let me draw on here. Woohoo! Nope. All right, I was going to show you a trend line, but they won't let me, so we'll get to that on the next one. And then, of course, you can check your answers and, ooh, pretty. All right, if you need help with graphing, please see me to help you out with that. Now interpret your graph. Once you plot your data, look at the graph and see if you notice any relationships between the independent and dependent variables. There is a relationship here. Okay, would we call this linear? Yeah, I'd say so for the most part. We would say when the volume increases, the mass increases as well. You can see that as the volume increases, so does the mass. If the volume decreases, the mass also decreases. The points show the general relationship between the independent and dependent variables, but a line that describes the relationship may allow you to make a better interpretation. The data points show a trend between mass and volume. As volume increases, mass increases. A trend line shows the relationship between the independent and dependent variables. When you draw a trend line, you don't, as in do not, try to connect the dots. You draw a line that shows the general trend of your data points. The line crosses the y-axis at 90 grams, which was the weight of the graduated cylinder alone. This point is called the y-intercept, or B. So it's the y-intercept because that's where it happens to cross the y-axis. The fact that it was also your starting point just happens to be the way it is. And the B comes from your slope equation, y equals mx plus b. Any line can be described by the slope-intercept equation, y equals mx plus b, where m is the slope of the line. The slope of the trend line represents the ratio between the independent and dependent variables. So your trend line shows the overall relationship between the variables. The slope of the trend line represents the ratio between the independent and dependent variables. Not all graphs are linear. This graph shows what happens in a sealed chamber to pressure, which is the dependent variable, when you change the volume, the independent variable. This could happen with a piston that presses down inside a cylinder, like in a car engine. Notice that as you increase the volume, the pressure decreases, rapidly at first, then more slowly. So for example, when my volume starts out at half, my pressure is 5. When my volume goes to 1, my pressure goes all the way down to 2. But when my volume is 2, my pressure is 1. When my volume is 3, my pressure is about 0.7. So you can see that the pressure doesn't fall evenly or in a nice line. The relationship between pressure and volume of a gas at a constant temperature is shown in the graph. It is a nonlinear graph, which shows a nonlinear relationship between the variables. Graphs relay useful information in chemistry. Graphs can help chemists visualize relationships between variables. Data from experiments should be organized into a data table before creating a graph of the data. To make a graph, follow these steps. Number 1, draw and label the x-axis on which you plot the independent variable. 2, draw and label the y-axis, which will show you the dependent variable. 3, decide on the scale of each axis and divide the axes into equal intervals. Scale each axis using even intervals. The scale of the x-axis does not have to match that of the y-axis. 4, plot the data points. 5, draw a trend line. 6, title the graph. Graphs show relationships between data. Graphs organize data. Graphs plot the dependent variable on the y-axis. Graphs plot the independent variable on the x-axis. Okay, we got to add some stuff to our notes now. I added to our notes y equals mx plus b. M is the slope of the line. Remember, slope is rise over run. B is the y-intercept, where the line hits the y-axis. So in this case, what would our B be? It would be 90, because 90 is where the line hits the y-axis. The trend line, also called the best fit line, shows the relationship between the data. You can use this line to predict other data points. So, for example, if, sorry about that, try again. All right, if we look, we know that when our volume was 20, our mass was about 145, okay? And no, that's not exactly where the line is, but the line helps us predict. And so let's say I put in 35 milliliters. I could predict and say, what would the mass be? Well, if I said 35, that would hit right here. I would go up to my trend line. I would go over and say, I would estimate at 35 milliliters that my mass was 170 grams. So let's try another one quick. What about if I said at 15? At 15 milliliters, what would my mass be? Hit pause, get your answer. Go up to the trend line, I go over, and I'd say, oh, about 125. And so that's the big key part of the trend line. Now, to be perfectly honest, I really don't love this trend line because it doesn't have to go through a point. And see how they have 1, 2, 3 points above it and only 1 point below it? It's not really balanced. I would say that this would be a better trend line because it's going through a little bit more and you have one above, one below. Oh, that one's below, so maybe I'd angle it just a tiny bit, which of course it's not letting me do. And you can be like, oh, you pretty much got the same line they did. Yep, so maybe they had the same problem. They couldn't get it exactly where they wanted. And that happens sometimes. There we go. So I'll do it that way. And now you can see that I have one tiny bit below, tiny bit above. And you know what, let's change the color of this so it's easier to see. There we go. And one above, one below. So this would be a much better trend line because it hits as many points as possible. All right. Then I also added nonlinear relationship. And our nonlinear relationship is the trend line is a curved line. For example, pressure decreases a lot at first and then decreases more slowly. So it really has a big dip, kind of a dip, and then it really levels out. And then, of course, as a reminder, if I didn't start my graph at 0, 0, I got to have those little M's, those little zigzags, in order to say, hey, I cut my graph and I glued it together right there. They are, I think they're called break lines, like you take a break. So that's it for this lesson. As always, if you have questions, let me know.